this paper today. Hi, Trishal. Hi, Kimora. We are finishing this paper today. I'll be answering from question 31 to 40. All right. So we're going to begin now. Question 31. The measure 2 meters, 50 centimeters is put into the number machine below. 3 numbers, we have 3 shapes here to represent numbers, are missing. Write the missing numbers. So we have 2 meters and 50 centimeters. All right. We add 3 meters, and this shape here represents a number 70 meters is equal to 6 meters and 25 centimeters. Now, how are we going to solve for what is missing? How are we going to solve for this shape? What is missing in this shape? How are we going to solve for this? We have to subtract. Okay, so I'm going to subtract 6 meters and 25 centimeters. I'm going to subtract that from, hold on, let me just change. Okay, good. 6 meters and 25 centimeters. I'm going to subtract that. I'm going to subtract 2 meters and 50 centimeters from that. And I'm going to get what this triangle represents. Okay, so let's subtract. 5 take away 0 is going to give me 5. Could 2 take away 5? No, so I need to borrow 1 from the 6. I'm going to remain with 5. Great, so now I'm going to have 12 take away 5 is going to give me 7. 5 take away 2 is going to give me 3. So it means that this triangle here, what's missing? 75 centimeters. Okay, this question wasn't so bad, wasn't it? Right, and now we have 6 meters and 25 centimeters multiplied by 5. Multiply by this shape is going to give us 18 meters and 75 centimeters. So now we have to multiply to get our answer. All right. Could anybody tell me what operation I should do to solve for the next shape? It says that 6 meters and 25 centimeters multiplied by a number is going to give us 18 meters and 75 centimeters. Any idea? I'm looking at my chart. Any idea in terms of what operation we should do to get the answer? We can divide. Yes, we can divide to get the answer. Yes, so we can divide 18 meters, 75 centimeters divided by 6 meters and 25 centimeters. I mean, even just by spotting this, we can already see what we are getting. All right, why? Because we know our tables very well, don't we? Don't we, Trishal? How much times could 6 go into 18? How much times could 25 go into 75? 3 times. So this is telling me that I have to multiply by 3. Are we seeing that? So 6 meters and 25 centimeters multiplied by 3 is going to give me 18 meters and 75 centimeters. So we just solved for the triangle and we got 75 centimeters. Now, for the next shape, 1, 2, 3, 4, 5, 6, this hexagon, 6 sides, we are getting 3. Okay, now we have 18 meters and 75 centimeters, subtract 17 meters and 95 centimeters. Okay, now 18 meters and 75 centimeters, subtract 17 meters and 95 centimeters is going to give us what? Now we need to subtract to get our answer. So if I have 18 meters and 75, sorry, 95. Sorry, let me erase this. 75, that is. 75 first. Good, so 18 meters and 75 centimeters. Subtract 17 meters and 95 centimeters. Those are our numbers. And now we are going to subtract 5 take away 5 is going to give us 0. 7 cannot take away 9, so I need to borrow 1 from my 8. So now I have 17 take away 9. What am I getting? 8. Watching my board here, 8. 7 take away 7 is 0. 1 take away 1 is 0. So we are getting 80 centimeters. So what we did was find the value for each shape. Okay, so we found the value for each shape. So let's scroll down a bit. Right, so we know what the triangle is, we know what the hexagon is, and this our next shape here, regular polygon, we know what it is. So we are moving on to question 32. Okay, question 32. I need to scroll up a bit. Kareem has 48 meters of wire to construct fences around 2 square plots of land. The area of the first square plot is 4 times the area of the second square plot. All right, let's read the question again. Kareem has 48 meters of wire, okay, to construct fences around 2 square plots of land. The area of the first square plot is 4 times the area of the second plot. They are saying shade the area on the grids. Shade the area on the grids above to represent Kareem's 2 square plots. Okay, how are we going to approach this question? Any ideas? Is it very tricky? So again, let's read it one more time. That's what you do. You read questions more than once, all right? Kareem has 48 meters of wire to construct fences around 2 square plots of land. The area of the first square plot is 4 times the area of the second square plot. Shade the areas on the grids above to represent Kareem's 2 square plots. All right, so what I'm going to do, I know they give me a grid here, but I'm going to draw a bit. Just think of it. They give us, let me draw here. Did I draw? Okay, I need to draw here. Let's look at this. Look at my drawing, okay? They're telling us that the area of 1 square, this space is not good enough for what I want to draw, okay? So I'm going to create a space where I can draw to show you something. We will shade on what they gave us shortly. All right, we'll shade on what they gave us shortly. Right, so can I draw? Am I getting some draw? Okay, I need to, 1 second, y'all. Right, so just picture this. This is a big square plot, all right? And they are telling us that one of the plot, okay? Right, so one, it says here that the area of the first square plot is 4 times, look at this, the area of the second square plot. So the second square plot, all right, is smaller. That's the first thing. And the area of this square plot is 4 times the area of the next square plot. So what do we need to do here? Now, I drew this just for you to see this. Now, let's just check this. In this first square plot here, how much sides do I have here? I have 1, I have 2, I have 3, I have 4. I have 4 sides. So now, and notice it's a square. So not from my drawing, but what they said is square plots. Okay, so this is a square. All right. Now, from what they're saying here, if we notice here, I have 1, 2, 3, 4 equal sides in a square. We need to know that. All right. There are 4 equal sides in a square. So out of his 48 meters of wire, I would need 4 equal lengths to fence this area. Okay. Now, if I need 4 equal lengths to fence this area, how much, let me put this in 4s, Yeah, it's 4 times the amount. I need 4 equal lengths. Are you all getting me? 4 equal lengths for this area. How many more lengths do I need? Equal lengths do I need? In addition to the 4, I need here needs to be fenced, here needs to be fenced, here needs to be fenced, here, 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 here. All right, so let's check and see how much equal lengths we need to divide this 48 into. All right, so in addition to the 4, we have 5, 6, 7, 8, 9, 10, 11, 12. All right, so I drew this drawing to show you that we need 12 equal lengths of wire to be able to fence, okay, his square plot. So what I'm going to do, I'm going to divide this 48. I am going to divide 48 by 12, okay? I'm going to divide 48 by 12. So we are going to say 12 into 12 is 1. You all understanding? And 12 can go into 48 4 times. So it means that the length that I'm going to need, okay, is going to be 4. So if I draw, I'm starting with the smaller one first, sir. 4, 1, 2, 3, 4. Notice they tell me the measurements. One of this represents 1 meter. So if I come across 1, 2, 3, 4, and I come down, it's a square. A square has 4 equal sides, okay? I'm going to come down 4. 1, 2, 3, 4. And I'm going to come down 1, 2, 3, 4. I'm going to go across 4. 1, 2, 3, 4. I'm going to go up 4. So notice, okay, y'all, I'm going to make my lines straighter, okay? I'm going to make my lines straighter. So I'm going to come across here 4 times. I'm going to come down here 4 times. I'm going to come across here 4 times. All right. So this is going to be my small plot. All right. And they want us to shade the area. So, okay, you shade the area, you color the area. Now, what is the area of this small square plot? If one side represents 4 centimeters, the other side will also represent 4 centimeters. Okay, so to find the area, we need to multiply. So 4 4s are 16. So the area of this small square plot is going to be 16 meters square. Now, if the small side, are you all getting it? If the small side is going to be 16 meters square, they told us that the area of the first square plot is 4 times the area of the second square plot. So it means that we have to multiply. I can multiply what? 16 meters square. I'm going to multiply this by 4. What am I going to get? 16 by 4 is going to give me, let me write it differently so that I can work it out. 24 comes here, 4, 5, 6. So the area of the first square plot, which is 4 times the area of the largest square plot, is going to be 64 meters squared. Now, they told us, hi everyone, so they told us that we need to shade it. So now what is going to give me the area of, what is going to give me the area of 64? How am I going to shade this rather? To represent the area of 64 meters squared. What can I multiply to give me 64 meters squared? What can I multiply to give me 64 meters squared? It's going to be 8 times 8. So that means, trying to draw it back. So that means I need to go across 8 times. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8 across. Okay, it's going to be 8. I'm going down as well. I'm going to come down 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm making sure I have the right drawing here. 8 across. So this is going to be, yes, 8 eighths. This is going to give me the area of 64 meters square rather. 64 meters square. Okay, and you'll be shading this area. You're shading this area better than me with your Pencil, of course, you're shading this area. Okay, and then remember what we had here? This one was 4. The area was 16. So here was 4 by 4. Okay, so I hope you understand this question. Again, the question asks us, it says that the area of the first plot is 4 times the area of the second plot, and the area of the second plot was 16 meters square, and the area of the first one was 4 times that, which was 16 by 4, which is giving us 64 meters squared. Okay, so that was question 32. Question 33, complete the symmetrical shape on the grid below using the line of symmetry shown. A very easy question. If I have, let me use, notice what we have here. We have 1, how much parts on this side? 1, 2, 3, these 2 make it 4. And then I have 1, 2, 3, here make it 4. I need to shade here. And if I shade here, then I am going to have, you remember this question? If I shade here, how much square grids am I going to have on this side? 1, 2, 3, 4. These 2 halves is going to make it 5 shaded squares on this side. Let's check the other side. 1, 2, 3. I have 4. I need another shaded square so that this side will also have 5 shaded square. Very easy question. That was question 33. Now on to question 34. Triangle ABC is a right angled, hear that? Right angle, y'all. Triangle ABC is a right angled isosceles triangle. What is an isosceles triangle? Answer. I'm looking at my board to see who is typing in the answer. What is an isosceles? What do we know what an isosceles triangle? An isosceles triangle has 2 equal sides and 2 equal angles. Okay. All right. So the question is saying triangle ABC is a right angled isosceles triangle whose angle B, that's down here, this is angle B, is equal to its angle C. Okay. So it's telling us that angle B is equal to angle C. Complete the drawing on the grid below to represent triangle A, B, and C. Complete the drawing on the grid below to represent triangle A, B, and C. So now, what do we know about an isosceles triangle? It has 2 equal sides and 2 equal angles. So if B and C has to be equal, all right, I'm going to draw, let's say, I can show you 2 ways. All right. I'll show you what will be wrong and I'll show you what will be right. Okay. So you are thinking of right angle triangle. I'm watching my board right now. So you remember this question. Nice. Now we're thinking of a right angle triangle, and sometimes what some students will do before working out this question, they'll say, okay, I need a right angle triangle. They're not going to think about the direction to draw it in. So they may just come straight across here like this. Okay. And they say, okay, then right angle. And then they say, okay, then this is C. But the question tells us, this is wrong. The question tells us that the angle B is equal to the angle C. And remember what angle B is. Angle B is 90 degrees. So if angle B, this is a right angle triangle. If angle B is equal to 90 degrees, is C equal to 90 degrees in this position? It is not. So that means that the drawing that we have on the board is wrong. All right. So we need to read the question and pay attention to what we are being asked to do. All right. They said that angle B is equal to angle C. So it means we're going to go over like this. 1. How much? Let's see. 1, 2, 3, 4, 5. We're going to go across 1, 2, 3, 4, 5. This will be your angle C. Okay, and this line here, 5 centimeters, 5 blocks, 5 blocks. So this line here and this line here, they are equal. And then this angle here and this angle here will also be equal. And this says right angle. So we have We are meeting all the criterias. All right, so this is how you do this question. Lovely, let's go on to question 35. The picture graph uses a scale factor to represent the number of cans collected by 5 teams. Altogether, the teams collected 120 cans. Good. The team collected 120 cans. Here we can see the different teams and the cans that they collected. I'm seeing whole cans. I'm seeing a few, well, 2, a half. So of course it will represent half. The question wants to know how many more cans did team 1 collect than team 4. Now we need to work out the scale. Okay, we have 5 teams. We have a total of 120 cans. Now, how much does each can represent? Okay, that's the first thing. That should be top priority. How much does each can represent? That's what we should be looking for. How are we going to work out the scale? Any ideas? How are we going to know how much each can represents? Anybody? How are we going to know this? What do we have to do? We have to divide, okay, and what are we going to divide by? We have 120, and we are going to divide by how much? How much cans do we have? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have 2 half cans here, which will give me 1. Is going to be 15. All right, so I have 120 cans in total. So I'm going to divide by 15. Okay, 15 into 1, 0, 15 into 12, 0, 15 into 120 is how much? Let's count in 15s, yeah? 15, 30, 45, 60. Anybody helping me? 75. Yes, count it first. Yes, very good. Yes, where will we? 60, 75, 90, 105, 120. How much times did 15 go into 120? 1, 2, 3, 4. I'm checking this. 1, 2, 3, 4, 5, 6, 7, 8. 8 times. 15 by 8 is 120. Okay, so each can represents 8. Okay, each can represents 8. That's the scale, all right? Can represents 8. Now, the question wants to know, I'm clearing here a bit for you. The question wants to know how many more cans does team A collect than team 4? Team 1 has how many cans? 1, 2, 3, 4. All right, remember each can is 8.5. So we need to add that to see how much team 1 has, and then team 4 has 8, 8, and this is half a can. So it's going to be 4. Do we agree with that? All right, so it's going to be 8 by 1, 2, 3, 4. So it's going to be 8 by 4, which will give us, what do you have there? 32. I'm not seeing it yet, but I'm seeing it. 32 and 4 is going to give me 36. And we have here 16 and 4 is going to give me 20. And that's going to be a difference of 16. Do we understand how I got that? So team 1 has 16 more cans than team 4. We can see that because team A has, and team 4, they have this in common, this in common, this in common. All right. So team 1 has 16 more cans than team 4. On to question 36. Okay, let's see this one. Let's read this one from the top. It says, Jay's Auto sold 5 different types of vehicles. The table below shows the number of vehicles sold by Jay's Auto during May. Okay, we have a table showing us the vehicles sold in May. It is telling us the type of vehicles and the number of vehicles sold. It says here that the owner of Jay's Auto wanted the mean number of vehicles sold in May to be greater. How many, this is supposed to be many, how many N is missing, sport cars should he have sold in May to increase the mean number of vehicles sold to 20? We're going to read this question again, all right? Jay's Auto sold 5 different types of vehicles. We get that. The table below shows the number of vehicles sold by Jay's Auto during May. Okay, the table is here. The owner of Jay's Auto wanted the mean number of vehicles sold in May to be greater. Do we remember how we find the mean? How do we find the average? Do we remember how to do this? Okay, when we are finding and when we are calculating mean, it's going to be the sum, okay, of all of this. I'm writing it 30 plus 20 plus 10 plus 25 plus 5 over how many, what are the different types we have here? What are the types of vehicles? 1, 2, 3, 4, 5. It's going to be over 5. And this is going to give us the mean. The question is saying that the owner of Jay's Auto wanted the mean to be greater, the mean number of vehicles sold in May to be greater. Okay? How many sports cars should he have sold in May to increase the mean? All right, number of vehicles sold to 20. So we need to find out what is the mean now. That's what we need to solve for. Add all the numbers. Yes, Trishelle. That's what we do. We need to find out the mean now. What is the mean now? So we need to add the numbers that we have. 50, 60, 70, 80, 90. We have a total of 90 over 5. And let's divide. 5 into 5 is 1. 5 into 9 is 1, with a remainder of 4. And 5 can go into 40. 8 times. So the mean is 18. Are we seeing this? Yes. Currently, the mean is 18. So we worked out the mean now. But here what it says, the owner of Jay's Auto wanted the mean number of vehicles sold in May to be greater. How many sports cars? How much is sold right now? 5. How many sports cars should he have sold in May to increase the mean number of vehicles to 20? So he wants the mean to increase to 20. How much vehicles needs to be sold? So what's happening here? Watch what I'm doing. I'm setting it back up, all right? The sum of vehicles is still 5. We're going to divide by 5. And he wants the mean to be 20. He doesn't want the mean to be 18. He wants the mean to be 20. So what sum goes on top here? What is the sum on top here? What sum goes here? To get this answer, we'll have to do the opposite operation. We'll have to do what? Multiply. This 5 is dividing on this out. We need to multiply 20 by 5, which will give us 100. Okay, so now if the number of vehicles sold, okay, adds up to 100, all right, he will be able to get a mean of 20. Do we agree with this? Yes. Excellent. He will be able to get that mean of 20. So now let's look at sports cars. How much sports cars were sold? 5. What is the total number that was sold in May? 90. So we need to subtract. What's the difference between 100 and 90? The difference is 10. So that means if he sold 10 more sports cars, all right, a total of 15. If he sold 10 more, a total of 15 sports cars, then he would have been able to achieve his mean of 20. So the answer, what they're asking us for, sports cars, all right? They want to know how many sports cars should he have sold in May to increase the mean number of vehicles to 20. So it means that he should have sold 15 sports cars. Do we understand this question? He should have sold 15 sports cars. Excellent. In order to achieve his mean of 20. Okay? Let's go on to the next question. Am I moving too fast? Question 37. The sum of every 5 numbers in the pattern below forms a new number pattern. Nice. Write the first 3 numbers in the pattern and describe them. We can do that. Let's read it again before we start it. The sum of every 5 numbers in the pattern below. So the sum of every 5 numbers, every 5 number in this pattern forms a new pattern. How many numbers do I have here? 1, 2, 3, 4, 5. So the sum of these numbers, of these 5 numbers here, is going to form a pattern. Okay. So now we need to determine what's going to be the next 5 numbers. 1, 2, 3, 4, 5. And those 5 numbers are going to form a pattern. And then we need to determine the sum of the next 5 numbers. 1, 2, 3, 4, 5. And those 5 numbers are going to form a pattern. Okay. So now we need to determine, okay, what pattern do we have here? What's this pattern? What's the difference between 3 and 9? What's the difference between 9 and 3? What's the difference? A difference of 6. Okay. 6. Let's see if we are, yes, 9 plus 6 is also going to give us 15. So already I can see here that the pattern is increasing by 6. Are we seeing that? So every time we add 6, 21 plus 6 will give us 27. Every time we add 6, are we seeing that? Every time the pattern is increasing by 6. So we need to add 6 every time. So yes, excellent. So 27 plus 6, I'm watching my chart. You all understanding? Excellent. So 27 plus 6 is going to give me 33. Right, it's not writing. Write in the next color. 27 plus is going to give me 33. Write in the next color. So 33 is coming on this line. Excellent. And 33 plus 6 is going to give me 39. And 39 plus 6 is going to give me 45. Are you all understanding? And 45 plus 6 is going to give me how much? 50, how much? 51 is coming on this line. One more to complete this pattern. And 51 plus 6 is going to give me 57. Very good. So again, when we add 3, 9, 15, 21, 27, that's going to be the first number in the new pattern. Okay. And then when we add 33, 39, 45, 51, 57, that's going to be the second number in the new pattern. Remember, they 1, 3. Okay, so let's identify. This is 57, y'all. Let me use a different color. Let's identify. Let's continue on to the next 5 numbers. So when we adding, we can add all one time. So here we're going to have, we have 57. All right, I hope you're seeing it clearly. Okay, right. So now 57 plus 6 is going to give us 63. And 63 plus 6 is going to give us 69. Okay, I want it to fit. And 69 plus 6 is going to give us 75. And 75 plus 6 is going to give us 81 and then 87. Okay, y'all? All right, so now that we have the patterns, we need to add. Okay, 3 plus 9 plus 15 plus 21 plus 27 is going to give me 75. What can we say about, anyway, let's write it. So the first number in the next pattern is 75. The second number in this pattern, I need to add my 33, 39, 45, 51, 57. I need to add this. It's going to give me 12, 17, 18, 25. Yeah, it's going to write 25 here. And I'm going to add on this side 20, 22, 25. Right. So notice I got my second number. So the pattern is 75. Then 225. Nobody's adding. Miss alone. Then I have 63, 69, 75, 81. And 87. Oh, 36951. I'm getting the same thing on this side. 25. Good. And I'm getting 12 to the 60s. Right, I'm getting 37. So my pattern is 75, 225, and 375 are the numbers in our new pattern. All right, so do we understand this question? It says the sum of every 5 numbers in the pattern below. When you'll see questions like this, don't just give up on it. You need to read it more than once and you need to attempt it. Okay, the sum of the 5 numbers in this pattern, it gives you a new pattern. So you saw what we did. We continued this pattern, and for every 5 number, what we did, for every 5 number, we added them. Okay, so we added it. All right, so do we understand what was done? 375. Thank you very much. Was that Katrina? Yeah. Okay, excellent. So let's move on to the next question. Oh, hold on. We need to describe this pattern, the new pattern. Sorry, let me write it out. That's what it's saying. Describe this pattern. We have 75, 225, 375. What's the pattern here? What's the difference between 225 and 75? 225 and 75. Anybody? What's the difference? What's the pattern there? Trishelle, I can recognize Katrina. Is Kamora there? Right. What is the pattern? So if we subtract, we're going to see that the difference between them is 150. So if I add 150 to 75, I'll get 225. And if I add 150 to 225, I would get 375. Do we understand this? Okay, so this pattern is increasing by 150. Question number 38. Question 38, I'm scrolling down. We're getting to 40, so we are almost to the end. Okay, we're on 38 now. Let me scroll up a bit more. The average mass of the 4 solids A, B, C, and D shown below is 1.5 kilograms. Again, the average mass of the 4 solids A, B, C, and D shown below is 1.5 kilograms. The average mass of solids A and B is 1.6 kilograms. The mass of solid C is 3 times the mass of solid D. What is the mass of solid C and solid D in terms of grams? Yes, I know a lot is being asked in this question. So you read the question over again and you begin to work on this question in parts. So the average mass of 4 solids A, B, C, and D shown below is 1.5 kilograms. The average mass of solids A and B is 1.6 kilograms. The mass of solid C is 3 times the mass of solid D. What is the mass of solid C and the solid D in terms of grams? Now, let's begin. That's why I don't like this question. It's okay, they are asking a lot. I know they're asking a lot, but we can take our time because they're saying what the average mass of A and B is 1.6. And we know how to find, we know how to work out average. We know how to do mean, right? We know how to do mean. Do we know how to do mean? Do we know how to do average? So then why are we stressing out on a question like this? The average mass of A and B is 1.6 kilograms. That's what I'm writing now. So it's telling us that the average mass of A and B, whatever A and B is, the average of that over, how am I finding this? It's 1.6. So that means, so what does that mean? How am I going to know the sum of A and B? I need to multiply, don't I? 1.6 by 2. Do you all agree with me? 2 times 6 is 12. But my point, 2 answer 2 and 1 is 3. Okay, so A and B is 3.2 kilograms. Anybody agreeing with me? Am I working it out too fast? Are you understanding? Okay, I'm trying my best to take my time and explain it step by step. Okay, so 3.2 kilograms. Now, this is A and B. It says the average mass of solids A and B is 1.6 kilograms. Now, the mass of solid C is 3 times the mass of solid D. What is the mass of solid C and solid D in terms of grams? So we just worked out this first part here. Any ideas on what we should do next? I'm looking to my chat. Say something. Say something. I'm taking it slow. We understood what we did just now, okay? What should we do next? We don't like the question. Okay, I understand. What should we do next? What should we do next? 3.2 kilograms. We worked out what is A and B is. What should we do next? We know that the average mass for A and B, we worked out what it is. All right? We worked out what it is. It's 3.2. So we worked out A and B. Now, you know what we should have done to start this question out? Look at this. Look what I'm seeing here. It says that the average mass of the 4 solids is 1.5. So, yo, I should have worked out this first. Let's do that. Of all 4, okay? So it means that A plus B plus C plus D, 1, 2, 3, 4, all of that, the average is 1.5. So what is the sum of all of this? I'm going to multiply 1.5 by 4. And I am getting 6 kg. Anybody seen that? They give me the average of all the 4. So I'm working out what the sum of the 4 solids are. The sum of the 4 solids is 6 kilograms, 6.06 kilograms. I just worked out for A and B, and the sum of A and B is 1.6. So I need to subtract 6, take away 1.6. Anybody agree with me? Not 1.6, sorry. What was A and B? A and B was 3.2. My apologies. 3.2. So that's what I'm going to take away. 3.2. Now I'll recap the question after I'm finished explaining it, okay? So 6.0, I'm going to subtract decimals. I need to take my time. I need to borrow 1 from here. I'm going to get 5. 1 is coming here. 10 take away 2 is going to give me 8. But my point here, 5 take away 3 is going to give me 2, which is going to be 2.8. So what I just did from the total, okay, of 6 kgs, I subtracted what A and B was. All right, so A and B is 3.2. So what do I have left is 2.8. Okay, I have 2.8 left. And what did they tell me? They said that the mass of solid C is 3 times the mass of solid D. So I need to divide this into how many parts? 4 parts. Because they said C, you all my 4 parts are not that equal, but you all get it, right? They said the mass of solid C is 3 times the mass of solid D. So with this 2.8, what I need to do is to divide. Do you all agree with me? I am going to divide. All right, so I'm going to divide 2.8 by, anybody? By 4. So it's 4 into 2.8. How much times could 4 go into 2? 0. How much times could 4 go into 28? 7 comes here. 4 sevens are 28. Okay, so it means that D would be what? It says that the mass of solid C is 3 times the mass of D. What is the mass of C and what is the mass of D? How are we feeling? Understanding it now? Better? So we know that 0.7 is the mass of D. I know D is 0.7, and they said that C is 3 times the mass. So it's going to be 0.7 by 3. Okay. Can I remove this? I need some space. And this question isn't finished yet. Huh? 0.7 multiplied by 3 is going to give me 2.1 kg. So here we have what D is, what C is, and what D is. Now, what did the question say? How do they want the answer? They say, what is the mass of C, solid C, and solid D in terms of grams? So now that we got the answer in kilograms, we now have to represent our answers in terms of grams. Now, that's very easy. We are just converting kgs, kilograms to grams. Yes, 1 kg, 1 kilogram is equal to how many grams? 1,000 grams. So it means that if I am converting from kilograms to grams, I need to multiply by 1,000. Multiplying by 10, 100, and 1,000 is very easy. Why? Because I simply need to shift my decimal point to the right. And I'm going to be shifting my decimal point 3 times to the right. Okay? I'm going to make some space for this one. So here I'm going to for C, I have 2.1. I am going to multiply it to 1,000. I have to shift my decimal point 3 times. I need to write it over like this so that you will see how I'm going to shift it 3 times to the right. 1. I need to add a 0. I need to add a 0 and shift it 2. I need to add a 0 and shift it 3. So I have C to be 2,100 grams. Okay, we see that? Are we understanding? Now I have 0.7. I'm going to write it so that you see it as well. 0.7. I want to convert it to grams. I need to multiply it by 1,000. Okay, when I am multiplying by 1,000, it's easy. All I need to do is to shift my decimal point to the right. So I have 0.7 and I'm going to move 3 times. 1. Add a 0, 2. Add a 0, 3. So I have 700 grams. All right, and this is my answer in terms of grams. All right, so I have what D and C is. Where is my C? 2,100 grams. Good. So do we like this question? It wasn't our favorite because it required a lot of steps. That's okay. We take our time. We read the question over and over until we determine what we need to do to get the answer. Okay, almost to the end, y'all. Question 39. It says on the grid paper below, draw the quadrilateral with 1 pair of parallel sides, 1 line of symmetry, and a straight line that joins the points A and B as its base. Okay, this is an easy one. Complete the drawing using the straight line that joins the point A and B as the line of symmetry. So if A and B is a line of symmetry, that means A and B is half the shape. All right. and describe the completed plane shape in terms of its angles, sides, and lines of symmetry. Do we like this question? Okay, I'm going to read it one more time on the grid paper below. Draw the quadrilateral with one pair of parallel sides, one line of symmetry, and a straight line that joins the points A and B as its base. Okay, complete the drawing using the straight line that joins the points A and B as a line of symmetry and describe the completed plane shape. Hear that? Plane shape, never said solid, plane shape in terms of its angles, sides, and lines of symmetry. So we're going to draw the quadrilateral. So I'm going to go up 1, 2, 3, 4. Let's see if I go up here. 1, 2, 3, 4, about here. Go across. So 1, 2, 3, 4. This is the quadrilateral I'm drawing. Anybody can tell me what shape is this I'm drawing? Anybody can tell me what shape is this I'm drawing? Anybody can tell me what shape is this I'm drawing? What does it look like? So it says complete the drawing using the straight line showing A and B as a line of symmetry. Okay, so this is the line of symmetry and describe the completed plane shape in terms of its angles, sides, and line of symmetry. So the plane shape that I drew here, I'm going to check the sides. Okay, this is 1, 2, 3, 4, 5, 6 sides. So this is going to be a hexagon. All right, and another line of symmetry. Y'all, I'm trying to be as straight as I possibly can. All right, so we have 2 lines of symmetry here. It says, draw the quadrilateral with one pair of parallel sides, one line of symmetry, and a straight line that joins, right? So this is a line of symmetry here. This is also a line of symmetry here. The plane shape is a hexagon. Anybody have any comments on this? It is composed of what? I have to describe the shape that I draw. I have 6 sides. I have how many angles? I have 6 angles, 2 lines of symmetry. AB is the line that I have here. All right. What do we think of this question? Complete the drawing using the straight line. What do we think of this question? Do we like it? We don't? Why? But you still can't leave questions, so that is, you still need to try. What shape would you have drawn? What shape would you have drawn? What shape would you have drawn? You're not sure? Let's go on to our next question. 5, okay, let's read this one. 6. This is our last question. 5 students ran 60-meter sprint races at Seaview Primary School. The times the students took to complete the sprint races are shown in the table below. Okay, so the times taken to complete the sprints are here. We have the different students. We have Troy, Andy, Jesse, Stacy, Chris. First sprint, what? Troy Cadrell sprint, 10.4. These are their average. His average is 10.2. Andy, okay, his own he started off very good. Okay, I can see that Andy is decreasing. If you look at each sprint, notice with Andy, yeah, it's decreasing. Okay, his average is 9.1. No, sorry, his average is 12 points. Okay. Jesse's average is, I'm going to read through the question. I'm just going through the table, all right? 9.8. Stacy's average is 10.1 and Chris' average is 10.2. Okay. I'm going to read this question again, okay, from the top. So 5 students ran 60-meter sprint races at Seaview Primary School. The time students took to complete the sprint races are shown in the table below. Based on the information given in the table above, state 3 reasons why an average is not a good measure, okay, to select a student to represent the race in a 60-meter sprint race, and select a student to represent the school, giving your reason. Okay, so they want us to select a student to represent the school and to also give 3 reasons why using the average is not a good measure. Now let's watch the pattern with some of these students and what's going on here. That's the only how we'll be able to answer the question, by analyzing the information that is given to us in the table. Okay, so we need to come up with 3 reasons why using, let's talk about this, 3 reasons why using average mean, why using average is not a good measure to select a student. Let's look at Troy. Okay, let's look at the person who has the highest average. That's what I will do. Okay, so Andy. Andy has, it's a very interesting, pay attention to Andy, y'all. Andy has the highest average. Okay, look what's happening here. He started off at 15. Each sprint, Andy is decreasing. Notice that? Each sprint, Andy is decreasing. But yet still, he has the highest average. So if they were just basing, if you just look at Andy's average, you will say, okay, Andy's the best student. Andy's the best student to represent the school. But if you look at what is happening to Andy, though he has the highest average, he's actually decreasing. His after his time is actually decreasing after each sprint. All right. Now look at Troy. Look at his average after each sprint. Look at Jesse. Look at Stacy. And look at Chris. So the question wants us to look at the table, analyze the information, and to give 3 reasons why average is not the best measure to select a student to represent the school. All right. So reason number 1. Now your average is going to be affected by your scores, by a low score. Let's say somebody is doing very well. If you just get one low score or one of their sprint wasn't good at all, it can affect their average. So average is not the most appropriate method to use in this case. Another reason is that average is not taken into consideration the trend in performance. All right, for example, if you look at Troy and you look at Stacy, let's look at Troy and Stacy. What's happening here? Troy is 10.4, 10.3, 10.2, 10.1, and 10.0. His average is 10.2. Look at this, look at this. Look at Troy and look at Stacy. Their average are almost the same. Okay, but there's 2 different scenarios here. Stacy is fluctuating in her performance and Troy is decreasing in his. All right, so another reason why average is not a good measure is because it's not taken into consideration the trend in their performance. Okay, who would you choose? My question to you now, based on what you're seeing here, who would you choose to represent the school? The student with the highest average, or you choose? Who would you choose to represent the school based on the averages that we are seeing here? Who would you choose to represent the school? I'm looking at my chat. Who would you choose, Trishelle, or who would you choose, Katrina? Who would you choose to represent the school? Who would you choose? Choose a name. So you're choosing Troy, Andy, Jesse, Stacy, or Chris. Whichever student you choose, you have to give a reason why you chose that student. Who would you choose? Not sure? Not sure who you would choose? I would look for the students that are showing improvement after each sprint. So let me go through and see who is showing improvement after each sprint. Okay, so who is showing improvement? Let me clear my board a bit. Let's see who after each sprint, how they're looking. Okay, I'll base my decision on that. Who is improving after each sprint? So anybody? Nobody choosing somebody? I'm giving you all time. This is the last question. It's just choose. Once you justify your answer, you're going to be fine, you know. Who would you choose to represent the school? Would you just resort to choosing a friend in this case? I'm not sure. Okay. All right, it's looking not to be sure. Who would we choose? The student with the highest average. It's easy to say Andy, you all have. Why would we choose Andy? Okay, so we choose an Andy. Why? Why we choosing Andy? Jesse, we want to see on which sprint who is clocking the least time. Let's look at. I'm going to look at sprint 5. I'm going to look at this sprint. I want to see who did the best in the last sprint. Who did the best? Who clocked the shortest time? All right. Who did the best? Who clocked the shortest time? Okay, I'm blocking you all. And that's the person I'll choose. Who clocked the shortest time? The person I clocked the short. Okay. Is Andy. So we can see that Andy improved over time. Actually, we're supposed to be watching for, it's a sprint, it's a race. So we want the person who is running the fastest, and the person who is running the fastest will actually be clocking a shorter time, will actually be taking less time to complete the race. All right, so in this case, I'll go with Andy. He improved, and if not Andy, who else? Well, then Stacy. But again, you see, my thing with Stacy, choosing Stacy is Stacy's performance is fluctuating. First, she did so well at 9.6, and then she went up. You know, so probably, yeah, Andy. Not because of his average, but because he improved after each sprint. So that's going to be my answer. I'm going to choose Andy. Somebody said Jesse. Jesse. Yeah. But you see, Jesse was clocking shorter times earlier. And then Jesse got tired, you know, and he didn't keep up. Right? So I will definitely, I saw more consistency with Andy. So my answer is Andy. Final answer is Andy, y'all. All right. Good. So this brings us to the end of our C 2021 specimen maths past paper. All right. My plan is to go through the ELA C 2021 specimen ELA past paper with you all as well, and see how that goes. All right. So thank you very much for joining me on our live today. Continue to be safe. All right. And remember, don't waste time. Spend your time revising, y'all. Okay. Make good use of your time.